Hello, everybody. Today we're going to look at C structures. What are structures? And we're also going to look at some examples. First, let's define what is a structure. A structure is another user-defined data type available in the C programming language. This kind of data type allows to combine data items of different kinds. Similarly, an array is a variable that can store multiple values, and all these values have to have the same type. So we're going to look at some examples. Let's start with a zoo. Let's say we have a zoo, and inside the zoo, we have different animals with different names. And let's define a variable that will store the name of our first animal. I'm going to call it first, going to call it name cow. The cow, its name will be cow. And the name of the cat will be cat name. That will be cat. We can display the information about these animals. That means we can have a printf. Then the name of the first animal will be the cow. And the name of the second animal will be the cat. Great. Let's compile this code and see what will happen. And execute. So we see that we have displayed the name of the cow and the name of the cat. Now let's say we have other information about these animals. For example, the cow age, which represent the age of the cow. Let's say the cow is of 5 years age and the cat is of 1 year's age. Int cat age 1. And we're going to complete that. Age will be the cow age. And the age of the cat will be the cat age. Compile this code and see gcc main.c, the O option, and we execute. Now we have the name of the cow and the age, and we have also the name of the cat and the age. Let's say we have other informations like the zoo names from where the cow is coming from, or maybe the name of the forest. I'm going to call it forest. So the forest from where the animals is coming from. Let's say the cow is coming from the Amazon. I don't know if there are cow there, but just for examples. And let's say the cow is coming from the desert. No, the cat coming from a desert. So the forest from where it's coming from is a desert. It doesn't make sense, but for the purpose of this demo, we're going to keep it funny. So the cow from the desert, forest, cow, and The cat will come from the desert. Forest cat. Yeah, there is a typo here. I'm going to rename it. Let's compile this code and see what happened. Now we have the information about a cow, the age, and where the cow is coming from, the forest. The same for the cat. So what you're seeing here is that both of these things are animals have kind of the same attribute and they kind of have the same informations, labels. But the problem is here when the more we have things, the more we are declaring variables, and that is not very, very convenient. For example, let's say you want to have a list of animals. You cannot store the information of those animals in a single array. For example, you want to have a list of animals. How are you going to do? You're going to first define an array that may contain, for example, 2 animals for the names. And you might also define an array for the age for 2 animals. You might also want to define an array for the forests for the 2 animals. Let's initialize the content of this array. The first one will be the cow and the cat, and the second one will be 5 and 1, and the third one will be Amazon desert and the desert. So this is how we define an array. We have defined 3 different arrays for each of these attributes in order to have a list of animals. And let's say we want to loop over these arrays and see what will happen. I'm going to comment out these lines and declare a variable called I. So for I is equal to 0, I lesser than 2, I plus plus, then we printf the name of the animal, then the age of the animal, then the forest where the animal is coming from. Then we need to access each of these array in order to have the required informations about a specific animals. Now we needed 3 different arrays in order to have to display information about the animals, which means that the data that describe an animal is spared, is divided into different arrays. And this is what is not very convenient, and that is where the structures are we are going to introduce structures so that we're going to have only one array that contains all the informations about a specific animal. Here we have a tuple. I'm going to correct that. gcc main.co main. Let's execute. We have a segmentation fault. Yeah, here we should have, you should add an I. Going to compile it. And now we have what? We have the cow, the age, and the first, yeah. And the last one, we have null. That means there is an issue in here. I'm going to correct it. Now the array have two elements. Let's compile it again. Now we have the information about the cow and the information about the cat. So these data or informations are stored in different arrays. It is not very convenient to have three arrays only to store data about our animals. This is why we're going to use structures. As we said, a structure is a user-defined data type available in the C programming language, and it allows to combine data items of different kinds. Let's define a structure in here. In order to define a structure, you type in the keyword struct and the name of the structure. The name of our structure is animal. An animal is represented by a name. An animal has a name. Let's say we're declaring an array that contain 20 can contain 20 character, and an animal has an age, and the last one will be the forest where the animal is coming from. Great. Now that we have an animal represented like that, we can create two different animals using this struct. This is a user-defined type that group different data types, data items of different kinds. We can access each of these data items by using the common name of the struct. Let's declare a struct for the cow. Struct animal. The animal is a cow, and we can initialize the name of the cow like that. Cow, age, name is equal to cow. Cow, age is equal to 5, and the cow forest is equal to 20. Nope, here we cannot use this kind of notation for strings. So we're going to initialize the animals here directly. We have to use str copy to copy strings into an array. But since this is not very convenient for us, we're going to just initialize the animals directly from the creation of the variable. So we're going to say the name of the animal will be a cow. Name is the cow. The age is 5 years old, and the forest is equal to Amazon. Now, this is a structure we created that represent a cow. And we also initialize each attribute of the structure using this notation, dot, then equal, then the value, the dot age, then equal, the age dot the forest, then equal Amazon. The same thing, we can do it for the cat. I'm going to delete this part, and let's define a struct for a cat. Animal, cat. To initialize the name of the cat, we have to put between the curly braces a dot, then name, then the name of the cat, then a dot, then the name, the age of the cat, 1 year old, and the forest from where the cat is coming from. This time I'm going to call it desert again. Just funny, but a desert is obviously not a forest. Now we have a cow and the animal. How are we going to display the information about these animals? I'm going to delete this one and use the printf function, printf names. Then here we're going to display the age. And here we're going to display the name of the forest. Now, in order to access a data item inside the structure, you type the name of the variable, then a dot, then the name of the data item. So cow.name, then cow.age, then cow.first. And next, we can also access the data for the cat, age, and what else? The first, where from where the cat is coming from. Now we have cat.name, cat.age, and cat.first. As you can see, it is much easier to understand this thing because all the data items about each animal is stored in a single record. You don't have to declare multiple variables just to have an animal. Let's compile this code and see what happened. There is an error. Expect a semicolon. Yes, when you declare a structure, you have to add a semicolon after. And let's run this code. Now we have cow, age, and the forest. We also have cat. It's a bit more organized and more understandable than the previous one. In the previous one, we declared 6 variables, but here we declared only 2 variables, one for the cow and one for the cat. Each of these variables are of a type struct animal, which means that they all have data item for the name, the age, and the forest. In order to access each of these data items, you type the name of the variable, then a dot to access one of the variable, then one of the data item, then the name of the data item you want to access for the struct. Next, the things that is most cooler is when you are declaring a list of animal. It's possible to declare more than one animal in an array to add multiple animals in a single array this time. So the type of the array is struct animal. Then now we have animals and we have 2 animals. We are going to initialize the array of animal. The first thing is for each animal, we have a name. So for the first animal, we have the name. dot name, that will be the cow, dot age, that will be 5 years old, and the forest from where the animal is coming from, Amazon. The next structure will represent our cat. Name is equal to cat, age is equal to 1, and the forest from where the cat is coming from is the desert. Deserts are not forest, but this is just for fun. Great. We now have an array of two animals. We have the first animal and we have the second animal that represent a cat. Next, let's declare a variable called I. For I equals 0, I lesser than 2, I plus plus, let's display an animal. The name of the animal will be that, then the age, and then the forest where the animal is coming from. So we have an animal at a position I in the array, then we say dot name animals dot age and animals at position I dot forest. Now we have one single array in which we have our animals, and each elements of the array represent an animal. It's much more understandable. Let's compile this code and see. Great, we have a cow and a cat.